Good morning, dear student. In today's lecture, we are very much interested uh, in the classification of composite based on reinforced phase. In previous lecture, we already discussed the classification based on the matrix constituent. Okay. So in today's lecture, we are very much interested in the classification based on reinforced phase. So reinforced phase is your dispersed phase. It is one of the constituent of composite, and it is not continuous. Okay, so this depending on this reinforced phase, the classification of matrix. Okay, they are classified into three types. The first one is particle reinforced matrix material. Second, the fiber reinforced matrix material. uh, Particle reinforced composite material. Okay, sorry, particle reinforced composite material, fiber reinforced composite material, and structural reinforced and structural composite material. Again, these particles reinforced composite materials are again classified into two types. One is large, and second is dispersion strengthen, so which increases the strength of the composite material. So they having large particles as well as the dispersion strengthen in particles. They are the macromolecules. So these particles, they are the macromolecules. So large particles and dispersion strength. The second important reinforcing phase is the fiber reinforce, in which we are very much interested, uh, because whatever the reinforcement, that is the glass, then second one is your carbon fibers, and then the aromatic fibers, they are included in this class, that is fiber reinforce phase. That is, it may be continuous or discontinuous. So the main constituent in this class, that is fiber reinforcement, is your glass fiber. Second one is your carbon fiber, and the third one is your aramide or aromatic fiber. Okay. So we are very much interested in the fiber reinforced phase of this composite material. So this classification is based on the reinforced phase. We already discussed the classification based on the matrix material. That is, we already discussed the polymer matrix, composite, metal matrix, ceramic matrix, carbon and graphite. Similarly, this classification based on the reinforced phase. First one is a particle, that is particulate matter is there. Okay, so they are having large particles as well as the dispersion strengthened particle is there. In fiber, there is a continuous and discontinuous reinforced phase, and they contain mainly the glass, carbon and aramide. Okay, and the last one is, that is your structural. This structural may again classified into two types, that is laminates and sandwich panel. The important examples of this reinforced phase, if you consider, that is your, if you consider the example of this particle reinforced material, that is your concrete. Because we know that the cement, it is act as a matrix material, and whatever the remaining material, that is particulate matter. Okay, particular aggregates, okay, whatever the aggregates, they are act as a reinforced material. And the important example of this particle reinforced composite is your concrete. So we are already discussed, that is the aggregates of quarries rock or gravel is embedded in the matrix of cement. Okay, so cement is your matrix. So the example is your cement is your matrix, and whatever the core is rock, and whatever the core is rock and gravel is your reinforcement. Okay, the example of this particulate. So we are not very much goes into details of this classification. So at least you should know the classification based on the matrix phase as well as the reinforced phase. Okay, so particle reinforced phase example is your concrete, that is the combination of cement and the core is rock or gravel. Okay, core is rock material. Okay, so small particles aggregates, they are reinforced into the cement and they are considered as a particle reinforced phase. The second one, that is your fiber reinforce. Okay, so different types of fibers are reinforced into this matrix material and which results into the formation of strong composite material. So let's discuss, that is we are very much interested into three important types of fibers reinforce into this matrix material for formation of composites. First one is your glass fiber. First one is your glass fiber. This glass fiber, if you consider this glass fiber, due to the relatively inexpensive cost. So the first point is that it having a relatively inexpensive glass fiber, it having a relatively inexpensive cost. Okay, and therefore they are most commonly used reinforcement. So relatively we can say that due to the relatively inexpensive cost, these fibers, that is glass fibers, are most commonly reinforce most commonly reinforce phase used in formation of composites. Okay, then the second one, that there are variety of types of glass. Second point is that, so variety of glass. Okay, variety of glass, and these are, so whatever the glass, they are they are all compounds of silica with variety of variety of metallic oxide, with variety of metallic oxides. So why these glass fibers are used in the formation of composite material, or why they act as a reinforcing material, why we reinforce into this matrix material? Because they are having a relatively inexpensive cost, the cost is very low for this fiber, and therefore these are the most commonly used reinforcing phase in this composite formation. Again, there are different types of varieties of glasses, and they are the compounds of silica with variety of metallic oxide. Again, why this glass is more popular as a fiber reinforced material for, okay, why this glass fiber is most popular as a fiber reinforcing phase? Because it is, so this glass fiber, easily drawn it is easily drawn into high strength fiber from molten state. So from the molten state we can easily convert into high strength fiber material. So it is easily drawn into high strength fiber from the molten state, and therefore this glass is so much popular as fiber reinforcing material. Second, the next point, it is readily available. It is readily available. It is readily available. Okay, and then the next important point, that when coupled with various plastic, it possesses chemical inertness. That is, when coupled with when coupled with various plastics. When coupled with various plastic, it possesses it possesses a chemical inertness. It possesses a chemical inertness. A chemical inertness that that renders the composite useful that renders the composite useful in variety of corrosive environment in variety of corrosive environment corrosive environment. So these are the some important reason why this glass fiber is so much important, or why they are act as a uh, popular reinforcing material for formation of composite, because it is easily drawn into high strength fiber from its molten state. It is readily available, and when it coupled with various plastics, it possesses the chemical inertness that renders the composite useful in variety of corrosive environment. Okay, again, if you consider the important properties of this glass fiber is that it having low electrical conductivity, it having high strength. So if you consider this property, it having high strength. Second, it having low electrical conductivity, low electrical conductivity low electrical conductivity. Third, and that is high chemical durability, high chemical durability high chemical durability. Fourth one, that is high stiffness. And the last one, that is your low dielectric constant. Okay, so we are discussing the classification based on the reinforcing material, in which we discuss the particulate one. That is, the example is your concrete. So in the next lecture, okay, in the upcoming lecture, we discussing the concrete in details. Okay, the second one, that is your fiber reinforcing material, in which the glass is there, carbon is there, and armide fiber is there. So why this glass is very important? Because it is relatively low cost is there. Okay, low cost, it can be easily drawn into high strength fiber from the molten state. Okay, and then when it react with other material, it will possesses the chemical inertness, and we can use this material in corrosive environment. Okay, so there is no effect of any factors on this material, and therefore the glass is very important. Again, if you consider this property, that it having high strength, low electrical conductivity, high chemical durability, high stiffness, and low dielectric cost. So let us discuss the second one, that is your carbon fiber. So let us discuss the second one, that is your carbon fiber. Carbon fiber. Uh, if you consider this carbon fiber, the high performance of fiber material that is most commonly used in reinforcement in advanced polymer matrix composite. Okay, so what is this carbon fiber? If you consider the high performance fiber material, so this carbon fiber, it is a performance high performance fiber material fiber material high performance fiber material that is most commonly used that is most commonly used in reinforcement that is most commonly used in reinforcement used as a reinforcements or used in reinforcement in advance. Okay, used as a reinforcement or used in reinforcements in advanced polymer matrix composites. Polymer matrix composites. Okay, so these carbon fibers, they are act as a reinforcing material in the composite made up by the polymer matrix. Okay, whenever the matrix is polymer and the reinforcing material is your carbon fiber, and then for such a composite material this carbon fiber is used, because the high performance fiber material that is most commonly used in the used as a reinforcement material in advanced polymer matrix composite, that is your carbon fiber. And why this carbon fiber used as a high performance fiber material in this composite formation, polymer matrix composite formation? The reason behind that, the first reason is that is it has it having it having highest highest specific modulus, it having highest specific modulus. So you should find out the definition of this specific modulus and what are the different terms involved in it. So it having highest specific modulus and high and it having highest specific modulus and specific strength of all reinforcing fiber material. So the first important point is that it having highest specific modulus and specific strength of all reinforcing fibers material. Okay, second, it retain their high tensile modulus, that is it retain their high tensile modulus and high strength at elevated temperature, at elevated temperature and therefore this carbon fiber is so much important. Next important point is that if you consider the third point, that is at room temperature, they are not affected by the moisture. So at room temperature, they are not affected by moisture and by wide variety of solvent as well as acid and bases. So they are chemically inert, we can say that at room temperature they are not affected by the moisture, and the wide variety of solvents and acid and bases. Again, if you consider these carbon fibers, these fibers exhibit a diversity of physical and mechanical uh, properties or characteristics. So the one more important point is that why this carbon fiber is very important as a reinforcing material for composite formation, because if you see this its property that it retains their high tensile modulus and a high strength at elevated temperature. At room temperature they are not affected by the moisture, and again these fibers exhibits diversity of physical and mechanical characteristics, or okay, they're having a different physical and mechanical characteristics and allowing these composites incorporating these fibers to have specific engineering products. So the next point is that if you consider the last point regarding to this carbon fiber is that due to the because of this carbon fiber exhibit, they exhibit a diversity of physical and mechanical characteristics mechanical characteristics mechanical characteristics uh, it allow it allow it allow composite it allow composite having having engineer uh, it allow composite having engineering application. It allow composite having engineering application. So this is all about the carbon fibers. One more is there, that is the armide fiber is there. Okay, the last one, that is your armide fibers. So we'll cover all these three. That is armide fiber. So what is this armide fibers? They are having high strength, high modulus material. So the properties are very common for glass, carbon and armide fibers. So the first one, that is having high strength, and they are having high strength. Second, they are having modulus high modulus they are having high modulus. Then and the third one, that is desirable for their outstanding strength to weight ratio. So they are having high strength to weight ratio high strength to weight high strength to weight ratio. Okay, which is superior to those of metal, which is superior over metal. Again, if you consider these armide fibers, chemically these armide fibers are the group of material. Okay, so they are the members. So if you consider the next point, that is chemically these armide fibers, chemically this or these armide fiber is known as polyparaphenoline tetrathalamides. Polyparaphenoline polyparaphenoline tetrathalamides. Tetrathalamides. So the chemical name of these armide fibers, that is polyparaphenoline tetrathalamides. They are having high strength, high modulus, outstanding strength to weight ratio, which is superior over the metals. If you consider these armide fibers are the most commonly used in composite having polymer matrix. So they are most commonly used in composite material made up by polymer matrix. Most commonly used in composite having polymer material as your matrix. Polymer material as your matrix, and this armide fiber is your reinforcement. Okay, most commonly used in composite having polymer matrix, such as epoxy and polyesters. Again, if you consider this material, it is known for its toughness, impact resistance. So another important point is that it having different properties such as toughness. So it is very tough. The composite material made up by this armide fiber, it is very toughness. Okay, then impact resistance, impact resistance, and resistance to creeps and fatigue failures. Resistance to resistance to cracks and fatigue failures. Again, uh, if you consider this armide fiber as compared to this glass and carbon fibers, they are susceptible to degradation by strong acid and bases. So the weak point regarding to this armide fiber, no doubts they are very useful, but as compared to the glass and carbon fibers, they are susceptible to degradation by strong acid and bases, but they are chemically inert for other solvents and chemicals. So this is all about the classification based on the reinforce phase, and we are very much interested in the fiber reinforcing materials such as glass fiber, carbon fiber, and armide fibers. In the next lecture, we discuss the important points regarding to the important examples regarding to this composite material, that is your concrete, and then second, that is asphalt. And in the next lecture we discussing some applications of this composite material. Thank you.